Hi class. Today we're going to be doing multiplying and dividing rational expressions. Notice that rational expressions I abbreviated to RE. Now let's talk about multiplying rational expressions. So if you have a fraction that looks like this, A over B times C over D, it's basically multiplying top with top and bottom with bottom. So numerator with numerator and denominator with denominator. As long as B is not equal to 0 and D is not equal to 0. If that's the case, then this will be undefined, that's not going to be our case. So let's talk about multiplying these, for example. The first step is to divide out any common factors. So let's see, between 9 and 7, there's no common factors, but there is between 9 and 27. So we're going to do that example over here. So 9. All right, so let's see. Between 9 and 27, do you have a common factor? Yes. The biggest common factors are 9 and 3. And this is really 9 times 1. Notice that the 9 and the 9 cancel. So the 27 just became a 3. And the 9 became a 1. Now let's see between 7 and 2. Nothing, right? So now we multiply 1 times 2. That gives you 2. And then 7 times 3. That gives you 21. So the answer for this problem is 2 over 21. And this looks like a negative sign, but it's not. So 2 over 21. We'll do negatives later on. 2 over 21. Okay, the steps are basically factor out all the numbers completely. That means factor out the numerators completely and factor out the denominators completely. And then you divide out by any common factors, right? And then the last step is to multiply top with top, bottom with top, bottom with bottom. Let's do another one with, and the same holds true when you're multiplying rational expressions that involve variables. So for example here, all right, I would first do the numbers. So let's see, 4 and 2. Okay, let's look at some of the factors, right? 4 is the factors, you have 2 and 2. And here, this 2 is really 2 times 1. This 2 cancels with that 2, and the 4 just became a 2, and that 2 became a 1. Between 3 and 9, the factors of 9 are 3 and 3. And notice that that 3 and that 3 could cancel. So that 3 became a 1, and that 9 became a 3. Okay, so let's multiply this so we don't have so much gibberish here. So 1 times 1 is 1. X squared times x is x cubed. Remember that when you're multiplying with the same base, you add the exponents. And here you have no longer a 4, but a 2. 2 times 3, that becomes a 6. And then here you have y squared times x becomes y squared x. Okay, you're still not done. Notice you have an x cubed here and you have an x there. This x is raised to the first power, and you have to subtract them. You always subtract the denominator exponent from the numerator exponent, but make sure you have the same base. So the answer would be x, so 3 minus 1 is 2, and you have 6y squared. Okay, so we can just double check. That seems correct. Let's go on to the following example. Now here, you have to step back and see, all right, do I have common factors between 4 and 7? No. How about 10 and 3? No. Let's check top and bottom now. Between 4 and 10, what do we see that we have our common factors? How about 2? 2 and 5 here, and 2 and 2 here. Notice that this 2 and that 2 cancel. So that 4 became a 2, and that 10 became a 5. Okay, notice also that you could also simplify top and bottom these x's, right? So this x goes away, that x goes away. Okay, so what else can do you notice? About that y squared and that y. This squared cancels with that particular y, right? So the whole thing cancels. And so let's multiplying, so we have less stuff here. So 2 times 3, that becomes a 6, right? We have a y, and then what? Times x cubed. And now the 10 became a 5. 5 times 7 is 35. And then you have to step back and see if you did everything correctly. All right, 4 and 10, 2 times 2, yes. The 2 and 2 cancel. And 10 is really 2 times 5. So the 2's cancel, so you have 2 over 5. Great. The x's cancel. And then you have y squared and y. Well, this y cancels and y remains. So you have 2 times 3 is 6 times y, and then that x cubed, right? And then here, 5 times 7 is 35. Okay, so that's 3. Let's do one more example of these particular ones, and we'll make it much more complicated. So here, you see here, check diagonally. 3 times 3, I'm sorry, the 3's have the same factors, right? 3 times 1, 3 times 1. Notice that they could cancel, and the 1 remains, right? The 1 remains. Okay, how about here? With 2 and 4, this is really 2 times 2, right? So the 4 became a 2. Here, what do we have? Let's see what's multiplied throughout the numbers first. Well, 1 times 2 is 2. X squared times y cubed becomes x squared y cubed over 1 times x becomes yx. Now you could see whether you could simplify the stuff that is the same. So let's see, the same factors. Y cubed and y. Notice that this y has a 1 here, and you subtract the denominator exponent from the numerator, and you write the same the numerator as is, right? And you will write something like this. You write y cubed minus 1, write this one, and then this x squared minus this guy here minus 1. And then you try to simplify. This becomes 2, 3 minus 1 is 2, and 2 minus 1 is just 1. So your answer is going to be 2y squared x. That's for 3b. Let's go on to do something more challenging, something like this. So familiarize yourself with something like this, where you have x minus 5 times 8 over x cubed minus 5x squared. Now, you could say that this, you can put it over 1, right? So you can make everything look nice. So I would write it as x minus 5 over 1, right? And what you should do first is see whether you could take out the greatest common, if there is a greatest common factor. And there is. The greatest common factor is the smallest exponent of the same base, right? So in this case, you have what? You have x times y gives you x cubed, x squared, and x times y gives you negative 5x squared, negative 5x. See, so if I multiply x times x squared gives me x cubed, x times negative 5x gives me negative 5x squared. And this you just bring it down, right? So this becomes x minus 5 over 1. Now notice that I made a simple mistake here. This x squared should have been here, x squared. And then this would have made everything else changes, right? So x squared times x is x cubed, and x squared times negative 5 becomes negative 5x squared. So notice that this x minus 5 is the same thing as this x minus 5, so therefore these guys are able to change. Now, let's see, 1 times 8, that becomes an 8, over 1 times x squared becomes an x squared. Notice I can leave the denominator x squared because it's positive. If I would have gotten a negative here, I would have moved that up. It would have been 8x squared, but this is the answer here. So you can never have negative exponents as an answer. So that covers number 4. Look at number 5. What do you see? First, you should step back and see, all right, what can I do in terms of canceling stuff off the bat? Well, the first thing I should see is this as 6x squared and that 3x. Notice that this 6 is really 3 times 2. So this 3 and that 3 cancel. The 3 becomes 1, right? And then you have x squared and x. That x squared, you could simplify, right? This goes away, that goes away, and we could rewrite it again. So it looks a little bit better. So you have x plus 2, which is squared. This is going to be twice, written twice, over 2x multiplied by, that's all gone, And then x squared minus 4 is the difference of squares. So a small review would be a squared minus b squared. That's a difference of squares. So you write a minus b, a plus b. So if I were to have another example, x squared minus, let's say, 81, right? So you have to say, well, this is a square, but 81 is also a square. So it would be x squared minus 9 squared. And how do you get this answer? Well, you circle everything below the 2, right, below the square. That's going to be one answer, x minus 9. And the other answer is going to be the positive of this, which is going to be x plus 9. Okay, so that's one particular example. So let's do this one. Notice that this one says x squared minus 4. Now, let's see. X squared minus 4. This is a square, and 4 is also, you could also make it a perfect square, right? It is a perfect square. So this becomes 2 squared. So what's the answer? Well, if you're able to circle everything under the 2, this becomes x minus 2 and x plus 2. This becomes here x minus 2 and x plus 2. So what happens now? Here, you start taking away stuff that is the same. This x squared and this x squared. What else? This is x minus 2 and that's x plus 2. You can't touch that. So your answer will be x plus 2 over 2x, x minus 2. With that, can you simplify anything else? No. Some students would like to simplify this and this, but you cannot do that. Notice that you could only simplify things, simplify common factors, not common terms. So you can always do, for example, you can do this, 2x. This you could simplify, but this you cannot. It remains like this. Okay, so let's do something more challenging, like number 7. Number 7, you have to know a lot of things. You have to know how to factor out many different things. And like, for example, x squared plus 7x minus 15. Now, let's do this particular problem here. So, step 1, when you're trying to factor a couple of things, is you write the first term twice, x and x. The third term is negative. If the third term is negative, that means that 1 is going to be positive and 1 is going to be negative. All right. So now you look at the factors of 15. What are the factors of 15? 1 and 15. And what? 3 and 5. Okay. So 3 and 5. Now notice that none of these examples, once you add them together, will give you 7. So that you can do. So let's change this 7 into an 8, right? So let's see, 5 minus 5, 2. Now let's make this a 2. Because now what's happening is, which of these two, when subtracted, will give you this, right? So what happens here, this is a 5 and 2. So the 5 is going to be the largest number, because the 2 is a positive number, and the 3 is going to be the smallest number. So you have x plus 5 times x minus 3. Okay, so let's keep on going with this example. Step 1, try to factor this trinomial. 2 parentheses, x times x. Look at the third term. If the third term is positive, it means you look at the second term to determine the sign of both. So it's minus and minus. And then you look at the factors of 3 that when added together give you 4. So you have 1 and you have 3. Okay? Okay, so let's keep on going with this. With this one, they already gave you a freebie where you could just write down whatever they told you. And then let's look at this one here. So this one is going to be, write 2 parentheses, x times x. If the third term is positive, you look at the second term to determine the sign of both. And the factors of 5 that add up to 6 are 1 and 5, right? So you put 1 and 5 here. And now you can step back and see what stuff you could simplify. All right, so notice here, x minus 3, this x minus 3, that can go away. What else? Well, x plus 1 and x plus 1 can go away. What else? This x plus 5 and then x plus 5 can also go away. And don't be tempted to take away these two, right? They're very different. So your answer is going to be 2x minus 1 over x minus 1. So you have 2x minus 1 and x minus 1. And with that, we end multiplying rational expressions. And in the next video, I'm going to be talking about dividing rational expressions.